1 plus sine negative 2x, we're first going to start by finding the transformations. Since it's plus 1, we know that it moves up 1. It is reflected of the y-axis because the x is negative. It is horizontally compressed because the 2 is inside the parentheses, the grouping symbol. So it's horizontally compressed by 2. To find the amplitude, we do the absolute value of the A. The amplitude would be 1 because 1 is the number that's in front of the sign. So absolute value of 1 would equal 1. The period, to find the period, use the equation 2 pi over b. And in this case, b is 2. Absolute value of b, which in this case would be 2. So 2 pi over 2 equals pi. To find the phase shift, you do negative c over b. And since c is 0, because there is no c, and b is 2, the answer is 0. Actually, in order to graph the equation, we'd have to change the original given points for a sine graph. So these are all given points. In order to find the points for this graph, we already know that it was reflected over the y-axis, it moved up 1, and was horizontally compressed. Because it was horizontally compressed by 2, we changed the x-coordinate to divide it by 2, and since it was reflected over the y-axis, we make the x component negative. And then, since it moved up 1, we add 1 to the y value. So, by doing that to each of these values, we found the individual point. So 0 over 2 would be 0, and 0 plus 1 would be 1. Pi over 2 multiplied by a half, which would equal negative pi over 4, and 1 plus 1 is not 1.
You've been gone for 3 weeks.
Is 2.
Feels like 3 weeks sometimes.
Pi 0 would become negative pi over 2, 1, because pi over 2 would become, pi over negative 2 would be negative pi over 2, 0 plus 1 is 1. 3 pi over 2 would be actually multiplied by negative 1/2, which would equal negative 3 pi over 4. Negative 1 plus 1 is 0. 2 pi over 2 would equal negative pi, because it's a negative sign. 0 plus 1 is 1. If you look here, the smallest space would be by a fourth. So we use the x-coordinate by every fourth, by pi over 4, because that's the smallest still. So once you put all these points on the graph, since it's a sine graph, you know that you just connect them like this.
Is it really?
This is 2 full periods.
To find the transformations of the graph y equals 2 tangent x over 2, you know that because it's multiplied by 2 on the outside, it's a vertical expansion.
And then I had them put it on colored sheets of paper, and I'll just give you those points. You can just
And then you know it's a horizontal expansion because it's multiplied by 1/2. And then to find the amplitude, well, there is no amplitude because we know that in a tangent graph, the max and the mins go all the way up forever. Okay. To find the period, you do pi over absolute value b, which in this case, b is 1/2. So pi over 1/2 equals 2 pi.
You guys did okay.
The phase shift is 0 because there is no c, and phase shift is c over absolute value b. So 0 over
We had like a
absolute value b, which is 1/2, equals 0. Oh, to find the new vertical asymptote of the graph 2 tangent x over 2, you use the 2x, 2y, which we found because there was a vertical expansion by 2, so that you multiply you multiply the y by 2. And then there's a horizontal expansion by 1/2. So since it's an expansion, you have to multiply it by 2. And so to find the vertical asymptote, you apply the multiplying 2 times x to here. So this becomes 2 times negative pi over 2, which equals negative pi. And then to find the new point, you do apply this again, which becomes negative pi over 2, and then negative 2. And this stays 0, 0, because 2 times 0 equals 0. And this, that's the x-intercept. And then this point changes from pi over 4 to positive pi over 2, and just to 2. And then this vertical asymptote becomes just pi. So then, because it's pi over 2, that's going to be the starting point that we use. So negative pi over 2, negative pi, because that's negative 2 pi over 2. And then pi over 2, pi. And then we're going to keep going because we need 2 full periods. So 3 pi over 2, and then 4 pi over 2 is 2 pi, and then 5 pi over 2, and then 6 pi over 2 is 3 pi. So we first draw our vertical asymptote, which is negative pi, and pi. Oh, and then the x-intercept. And then since we're drawing 2 full periods, 2 pi and 3 pi. So first we're going to graph our first point, which is, we need to do 1 and 2, and then negative 1, negative 2. Okay, so negative pi over 2 goes down to 2. So we have that there, and then you draw your line or curve, and then pi over 0, 0, which is our x-intercept. And then you draw your pi over 2, 2, which is right there, and you draw your line / curve for that. And then we keep going and double it because we need 2 full periods. So negative 2, 3 pi over 2, and then 5 pi over 2, positive 2.
In order to solve the equation y equals negative 1/2 secant x plus pi, we're going to start by finding the transformations. Because it's plus pi inside the grouping symbol, we know it moves left pi. Because the whole equation is multiplied by negative, we know it's reflected over the x-axis. Because 1/2 is outside of the grouping symbol, we know that it's vertically compressed by 1/2. There is no amplitude in this equation because it is a secant graph and the curves extend infinitely in both up and down directions. To find the period, you do 2 pi over b. In this case, it would be 2 pi over 1 because the coefficient of this equation is 1. So that becomes 2 pi. To find the phase shift, you do negative c over the absolute value of b. In this case, negative c over b would equal negative pi over 1 because pi is c and 1 is b. Right there. Okay, so that would equal negative pi. When it comes to graphing the equation, we have to change the coordinates of the graph to fit the transformations that occurred. These are the given points for a secant graph. To find these, we did x minus pi for the x, and for the y, we did negative y over 2 because of the transformations left pi and then vertically compressed by 2 and reflected over the x-axis. So when you go to each point for the asymptote, negative pi over 2, we're going to do what we did to the x component, and we subtract pi to get negative 3 over 2. To get 0, 1, we're going to put the 0 here and get 0 minus pi, which is negative pi. Then negative 1 over 2 would be negative 1/2. Pi over 2 minus pi would equal negative pi over 2. pi minus pi would be 0, negative 1, negative 1 would be 1 over 2, so 1/2, and then 3 pi over 2 minus pi would equal pi over 2. So to graph this, we're going to decide what to do for the x-axis, and because our smallest number would start with it's going by half, we'll do pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. So we're gradually going by half, or pi over 2. And then when you go this way, you go negative pi over 2, negative pi, negative 3 pi over 2. So to graph this, we're going to put each point onto the graph, and then do the asymptotes. X equals negative pi over 2. We're going to put asymptote here. Asymptote at pi over 2. And one at 3 pi over 2. And because we're going to have to graph 2 full periods, we're going to go ahead and, because they're increasing by a whole pi, we're going to go over here, 1 pi, and know that an asymptote goes here, as well as on this side. So on a secant graph, you're going to draw it like this and stay inside of the asymptotes. And that makes 2 full periods.